So again, problem 7 states, evaluate the improper integral or show divergence. If on the sample final there's going to be two parts to this problem, a part A and a part B, then I'm pretty darn sure that on the final exam there's going to be a part A and a part B. I'm also pretty darn sure that one of the example it's going to converge and one of the example that's going to diverge. I don't know which one it is, which one's going to converge and which one's divergent, but I think the procedures that we have to solve the problem is going to be the same. Now, when we evaluate this improper integral, please note that on your exam, you will have to use you have to use limits, right? So you can't use any p-value method here. You could use a p-value method to check, but you have to use your limits. So let's show it part A first, and then I'll do part B. Hopefully I could do both parts on the same screen. So let me just split this in half. All right, so for part A, we have the limit as b approaches infinity of 1 to b of 3 over x to the fifth dx. So first thing I noticed was that in this integral, for part A's example, our upper limit of integration was infinity, and I'm replacing that infinity with b and then rewriting in terms of a limit. In addition, I am now going to rewrite this integral and then try to compute it. So the way that I'm going to rewrite this is as follows. I am going to take the 3, that's my constant multiple, I'm going to stick it out of the limit, and because my variable term is in the denominator, I'm going to bring it up into the numerator. So this will give us 3 times the limit as b approaches infinity, from 1 to b of x to the negative fifth dx. Now what I'm going to do is integrate it. We're going to get 3 times the limit as b approaches infinity. In my brackets, I'm writing out my antiderivative. Antiderivative of x to the negative fifth is x to the negative fourth over 4, or negative 4. Remember, you have to add 1 to the exponent and then divide by that sum. And then I'm going to write out my limits of integration here. We have x equals 1 to x equals b. Now, before I evaluate this antiderivative here, what I'm going to do is also pull this negative 4 out, and the negative 4 that's from the numerator, or x to the negative 4, I'm going to bring it down into the denominator. Okay, so this will give us 3 over negative 4, or just simply negative 3 over 4, times the limit as b approaches infinity of 1 over x to the fourth, from x equals 1 to x equals b. Now, if I evaluate this limit, if I plug in my limits of integration, we get 1 over b to the fourth minus 1 over 1. But I know that as b goes to infinity, 1 over infinity to the fourth is going to be a relatively small number. That's just going to convert or become 0. So we get negative 3/4 over times 0 minus 1. 0 minus 1 is negative 1. So negative 3 over 4 times negative 1 is positive 3 over 4. So for this improper integral, we know that it will converge essentially to 3 over 4. And that's the solution to part A. If you want to solve part B, on the other hand, what you'll need to do here is, again, identify that your upper limit of integration is infinity, so you need to rewrite in terms of a limit. So for here, you're going to get the limit as b approaches infinity, from 1 to b of x to the power of negative 1 over 5 dx. You can go ahead and integrate this. There's nothing to rewrite for this integral. So you get limit as b approaches infinity from 1 to b Well, sorry, I'm computing the integral, so I don't need the integral symbol there anymore. I need my brackets. If I do -1/5 plus 1, this is essentially 4/5 because you could rewrite the 1 as 5/5, right? So 5 minus 1 is 4. So we're going to get x to the power of 4/5 divided by that sum, 4/5. Now, this is also our limits of integration goes on the outside, so it's from x equals 1 to x equals b. Instead of dividing by this fraction, 4/5, you can multiply by the reciprocal. So if you flip 4/5, it will become 5/4, and I can pull it out here, right? So this is going to equal to 5/4 times the limit as b approaches infinity of x to the power of 4/5 from x equals 1 to x equals b. Now you can go ahead and plug in your limits of integration. You get, let's see here. You will get b to the power of 4/5 and then 1 to the power of 4/5. Well, we have the 5/4 on the outside. In the parentheses, if I evaluate the limit as b goes to infinity, you'll get infinity minus 1. So when you work out all the arithmetic here, you'll get infinity, so it diverges. And that would be the solution to problem 7, parts A and B.